This is the Insta360 X4, and it's one of the best 360 cameras out there with its 8K resolution and insane stabilization. But what does it have to do with Blender? Well, it allows us to easily and very quickly capture a 360-degree photo that we can later use as an environment map in our visual effects scenes. That allows us to get accurate reflections on smooth surfaces, which in turn makes your renders more believable. So let's see how this is done. I'm Dude Blender.
Let's get it on!
First, let's get the settings of the camera ready. So let's turn this on. We tap here on the camera icon, make sure that 360 is active, and select HDR photo from the menu. An HDR takes several exposures and combines them into one picture so that highlights and shadows are all exposed correctly. Next, tap here at the bottom and select the highest resolution. Here it is 72 megapixels. And then set a 10 or 15 second timer so that you have enough time to get out of the shot. This menu on the right, I just leave it in Ultra, and I'm not really sure if it makes any difference for this application. Okay, that's all the camera setup. Now let's take it outside. I've placed the camera in its tripod as close as possible to where the reflective object will be. The camera, tripod, and shadow will all be covered with the 3D model that we're gonna composite on top of this. Now that we have the footage, I'm just gonna take a picture with the 360 camera, and then we'll put everything together. When you connect the camera to the computer through a USB-C cable and turn it on, it will automatically go into the file transfer mode. An Explorer window will open to the camera's card folder. The photos have a .insp extension, which is a proprietary format of Insta360, meaning that we're gonna need to install the software to open it, and we can download that for free from their website. This is what you'll see when you open the file. If you click here on Switch FOV and click on Equirectangular Panorama, you'll see how the 360 photo will actually be exported. So we just go ahead and click on Export, make sure that Export 360 Photo is selected, and here you can change the name and the location of the file. Unfortunately for us, these guys were not thinking about VFX artists. I just know that they don't allow us to change the output format. And adding insult to injury, they gave us the worst possible one, the most compressed and with the most loss of data, the freaking JPEG.
What were they thinking?
If they had given us an EXR format, which keeps more color and especially brightness data, then we could have used that image to light the scene, which would have been insanely useful. But anyway, this will have to do. So click on Start Export, it'll take a few seconds, and then we'll get our image. Note that HDRIs can be done with any camera. You just need to take different exposures at different angles so that you capture the image all around and then stitch those images together. In any case, you'll see that this image is actually quite usable, even when these are literally the worst possible lighting conditions. High noon, direct sunlight, no clouds at all, and lots of shadows. Even if we zoom in, you can see that everything is decently exposed. We could remove the shadow of the camera and the tripod in your editing software.
I'm not doing it.
Okay, now let's get on with the good stuff. I'm just gonna take a frame of this video instead of the whole video because this is not a camera tracking tutorial. If I were to do that, the video would be at least twice as long. But everything that we learn here can be applied to video. Actually, do let me know in the comments if you'd like me to make a camera tracking tutorial for beginners. All right, let's go to Blender. Okay, so the first thing we're gonna do is we're going to delete everything in the scene because we don't need any of this. You might have the default cube, so A, X to delete everything, and just confirm the operation. So this is the image that I'm going to use. We're gonna load it into fSpy. If you don't have it, you can download it from their website, fspy.io. This application allows us to generate a camera based on an image that we open on it. Okay, this is fSpy. I'm just gonna drag and drop the image that we saw before, and this is what we get. So here on the left, you can change the number of vanishing points, 1 or 2. If you select 2, you'll see that you get 2 sets of lines. We can also change the vanishing point axes. In this case, I'm going to use X, which is going to be this axis, and Z, which is going to be this axis. The idea here is that we want to place these lines in lines or edges that we know are straight on the photograph. This will allow the software to calculate the perspective, the lens, and the sensor that were used to take the photograph. You can uncheck dim image if you want to see the original picture, and you want to make sure that the lines of the edges of the photograph that you use are parallel to the axes that you're using. So most of the time you'll have a building or an edge or two walls meeting, and you'll have that information. So we have this planter here. This is what we're going to use. So I know, or I can assume, that this edge is perpendicular to this edge. So this works. But if we didn't have any edge visible, we would not be able to use this image. You drag and drop the dots, and if you want more precision and a little bit of zoom, you can hold the shift key. So I'm going to place this here, this one there, then I'm going to bring this one here. I think that's the edge of the planter. Then here to the corner, we have that. Then the ones in the z-axis, so this one goes here to that edge, this one there, this one goes here, and this one here. You'll see that this is the other way around. So I want Z to be up. We can change that here from Z to minus Z, and then we get it right. This dot is going to be the origin on our scene. So just make sure that you place it on a relevant place and not, all the way here. Let's put it here. Now, when I use fSpy, I always want to see the 3D guide. So here it's off. Let's turn it on and use XY grid floor. So if you move the grid to the sides or up or down, the perspective should make sense. The perspective of this plane formed by this planter corresponds correctly to the grid. If you see that it's weird or the perspective doesn't match, you probably did something wrong and you need to fix it here. If you don't fix it, this won't work. So let me show you an example. Let's say I just used one vanishing point and I place the z-axis here. Something like this. So I might think that it's correct because I have both lines marking the x-axis and the z-axis here. But if I move the grid around, you'll see that it does not match the perspective of the scene. So yeah, we can tell that it's wrong and we need to do something to fix it. I'm just going to go back with two vanishing points. This one is correct. So I'm just going to place it here. Now, even if you don't know the distance, which is the case now, I don't know the distance here, you should at least calculate or estimate the scale for this because this is going to affect our scene. So here in reference distance, it says default. Let's click on along the x-axis and you'll see that we have these markers here. Okay, I also want the positive axis to be to the right. So I'm just going to change this to minus x. We can change these two endpoints along the x-axis. So I don't know the dimensions of this planter, but I can estimate it. And it's better to estimate something even if it's a little bit off than just not doing anything at all. I'm going to place this here to where the planter ends. So this marker would go here and the other end, I'm going to put it here, trying to measure this tile. So I don't know how long it is, but it's probably around 80 centimeters. So I'm just going to click here, 0.8 meters. And now that we have this, we are pretty much done. So File, Save, and save it in a folder where you have your Blender project. In this case, I already have one that is called HDRI. So I'm going to call it TUT Record. I'm going to save that, and we don't need this anymore, so we can close it. Now, here in Blender, if we have the fSpy add-on installed, you can go here to File, Import, and you'll see this menu item, fSpy. So click on that and then navigate to the folder where you have that file and just double click on it. So in this case, it's TUT Record, double click on that, and we get this. So what do we actually get? First thing we get is a camera. If we go to the properties, we get the field of view. I'm going to change this to millimeters. We get the correct focal length that was used to take that picture. We go to output. We also get the correct resolution of the image that we're using. In this case, it's a 4K image. Now, if we look through the camera by pressing 0 on the numbers pad, we also get the image, so that photograph that we're using, as a background image in the camera. So everything that we need is set up here. And finally, we also get the correct position of the camera based on where we place the origin. You can see that it's 1.5 meters more or less above the ground, which, it makes sense. We don't know if it's exactly right, but it does make sense. All right, so this is a lot of the work already done. Let's press 0 in the numbers pad to see through the camera, and let's go ahead and add a plane. Shift A, mesh, and plane. And you'll see that if I move the plane around, it's aligned with this axis, with this edge of the planter. If I move this in Z, this edge of the plane should be parallel to this edge of the planter, which it seems to be. I'm going to scale the plane in X. I just want to cover all of this. Okay, this plane is going to be a shadow catcher. Now I'm going to bring in the models that we're using. Now I'm just going to paste the models that I just had on a different file. I'm just going to rename them, this to sphere and this to column. I'm going to open a new panel here, hide this window, hide this too, 7, and I'm going to move this close to the origin. I'm also going to rename the plane to floor. And if I go to rendered view, we can't see anything because we have no lights. Let me hide this one too. So let's just go ahead and add a light. Sun. Now, the first thing that we want to do is match the lighting conditions of the original photograph. So we can do that by looking at the shadow. I'm going to select the camera, go back here, bring the image to the front with this button, and this way I can see both the real shadow of the object and the shadow that the sun is projecting. If I select the sun and just rotate it by pressing RR, I can set the angle of the shadow. Note that if you're using a sun lamp, it doesn't matter where you put it. The only thing that matters is what angle it's at. So in this case, what I want is that the shadow that the column is projecting is parallel to the shadow that was projected by the tripod and the camera when I took the picture. It's actually pretty good like this, so I don't think I need to do anything. So now this angle is correct. We need to place the column in a way that the base of the column matches, as best as we can possibly do it, the base of the tripod. So if we extended the line of the tripod and the line of the shadow, wherever they match would be the base of the tripod. So it would be somewhere around here. So we can just move this and place it there. I just want to make sure that it's actually on the base, which is not. So I'm going to move it up a little bit. And we want it to cover the whole camera. So I'm just going to scale it up like halfway there and move it up a little bit. Now we're covering the camera and the tripod with our model, so we don't even need to remove that from the photograph. One more thing to note, it seems to be that the tripod is at an angle, it's not straight up, so we get that we're not covering the shadow of the tripod completely. So we can rotate the column a little bit, or we can just move it. In this case, because it's a photo, it doesn't matter. If you were to do a video, you would want to rotate it, because if you move it to an incorrect position, whenever the camera moved around, you would be able to notice. So we're gonna do it as realistic as possible. In this case, let's just rotate it a little bit and place it there. And the shadow cast by the sphere should be just a little bit above the camera. So we need to change that here. So we select the sun, just move it ever so slightly there. So this is as realistic as we can get. I can select the camera and move the image to the background. Now we want the shadow to show in the image, but we don't actually want the plane to be visible. We're going to select the plane, go here to Object Properties, scroll down to Visibility, and we're gonna click on Shadow Capture. This will allow us to see the shadow, but not the plane. Next, we want to match the lighting. So let's select the camera, go here to its properties, and change the opacity of the image to 1. We want to see the real lighting of the image so that we can match it. Now select the sun lamp and increase the strength to something that looks realistic. In this case, probably around 7. The next thing we want to do is to actually have the reflection of everything on the sphere. So let's go ahead and do that. We're going to go here to World Properties, and we're going to click here where it says Color, not on the actual color because you'll get the color picker, but on the yellow circle. And we're going to select the environment texture. From here, we're going to open, and here we're going to select the image that we got from the 360 camera. So double click on it, wait for it to load, and now we have the reflection. So the next thing we want to do is make sure that the orientation is correct. In this case, we can see that it's not. So to fix that, we can go to Shading, change this from Object to World. With the image selected, press Ctrl T, and here we can change the rotation of our environment texture. We cannot see it here, so we can scroll here to the right by pressing and holding the middle mouse button and dragging. Click on this drop down, click on Scene World so that we can see our HDRI, and now let's go to Camera View. Then we just rotate until what we're looking at in the image matches the orientation that we're looking at on the HDRI. So it's just a little bit more there. So these are the bamboos that are here, and this tree is here. So in fact, I can go here, select the camera, go here to the properties, background image, and maybe make it a little bit transparent. So basically this planter, I'm gonna hide the floor for now. So this planter is this planter. So I just wanna be able to see both and just get the orientation the best you can. Okay, I think it looks good. Okay, let's go to opacity 1 again. Now we got the right orientation. So if I zoom in, you see that it's reflecting whatever was behind the camera when this picture was taken. Let's go back to layout. I'm going to unhide the floor. Now let's select the camera again, properties. Let's just give this a quick render to see what happens. Okay, so we have a few things that are correct. We have our model, we have the reflection, but we have a few issues. First, we cannot see the actual photograph that we want. We're just looking at the HDRI, which we don't want. And we cannot can also see the reflection of the plane. Even if we made it a shadow catcher, we can see the reflection of the plane on the sphere. So we want to fix those two things. Let's close this and let's go to render properties. For this type of composite, we actually do need to use the cycles render engine. So make sure cycles is selected here and scroll down until you find film. We want to remove the HDRI. We want it to contribute lighting and reflections, but we don't want to be able to see it. So we're just going to click on transparent. We're going to go here to compositing. And I know that nodes are intimidating if you've never used them, but we're going to do something that's really simple. So let's click here and use nodes. Okay, now we cannot see anything here because we don't have a viewer node. So we can Control Shift, left click on this, and now we get a viewer. I don't like the backdrop, so I'm just gonna turn it off. And here on this side, I have an image editor. So here we can just select viewer node. And now we can see our composite in this side of the screen. We can Shift, left click and drag here to make this a little tidier. So now what do we want to do? We want to have our image, our photograph in the background. Now in front of that, we want to have our sphere with our column, and then we have the camera. So this is what we want to achieve. So here with the nodes, it's super easy to do. So Shift A, image, and since the image that we need is already loaded in the scene, we can just select it from here. It's going to be the record fSpy. And now we want to place this image behind this render, something like this. So the way we do that is we select these two nodes, Control-Alt-0 on the numbers pad. That creates an alpha over node and it connects both inputs. Let's expand this and see what we have. So basically what the alpha over node does is it uses the first input as the background and then the second input as the foreground. Now this is our basic composite. It looks okay, but there's a few things that we're gonna do to make it look more realistic. So let's go back to layout. And the first thing is that this plane, even if we're not seeing it, it's contributing its color as a reflection to the rest of the models. If I hide it, you'll see that this becomes darker. Now, the thing is that we actually want this plane to be a color that is predominant in the actual place. Ideally, we would have all of these colors, the plants and this tin material and the other plant, all of those things, but that's actually kind of difficult to get, so we're not gonna do it. We're just gonna add a new material. Let's rename this to floor, and we're just gonna take the color of the ground here. So we just click here and we get a brownish color. So that color is going to be reflected in the column. Let's make the plane bigger. You can see right here how it changes. So maybe that's too much, something like this. I'm just going to make it a little bit bigger here. That's it. Okay, and maybe the sun is a little too bright. Let's bring it down to 6. The next thing we want to fix is removing this reflection of this plane. So that's actually very easy to do. We're going to go here to the object properties, go again here to visibility, and understanding this is actually kind of important because we use it in several places. So for example, when you want the render passes and you want to manipulate the image in a very specific way, you kind of need to know this information. What's a diffuse, a glossy, a transmission ray, all of those things. In the object properties, we can turn some of the rays on and off. So if we uncheck camera, we just don't see the plane at all, not even the shadow that is being cast on it. So we want that. If we uncheck diffuse, it's going to be hard to see, but a little bit of the contribution of the color is going to be lost. So we want to leave that. Now glossy is the actual reflection that you can see in very smooth surfaces like this one. So if we turn that off, it's gone from the reflection of the sphere, which is exactly what we want. So we are keeping the shadow, we're keeping the color contribution, and we're just removing the reflection. That's why understanding these is so important. It gives you a lot of flexibility on what you can do. Okay, let's give this a quick render and see what we have. Okay, this is actually looking good. So we're gonna get into the fine detail now. There are a few things we need to solve. First, the shadow here, because I was lazy and did not remove the camera shadow on the image, I kind of need to cover it correctly. That's gonna take us a little bit of work. Let's fix that first. The way that I'm gonna fix it is we're going to render the shadow in one layer, and we're going to render the model in a separate layer. This way, we can adjust the colors of the shadow by themselves without affecting anything on our model. The way we do that is we're going to take the floor, select it, and press M, move it to a new collection. We're going to call this collection Shadow. I'm going to move the sun to the scene collection and the camera also to the scene collection. It doesn't matter where they are, it's just to keep everything organized. So you have now two collections, the foreground, which has our models, and the background, which is going to have only the shadow. We're going to change the name of this layer to foreground, and we're going to create a new layer with this button, new, and call it background. Now, in the filters here, we have a few more that are by default turned off. We want indirect only. So in the background layer, we only want to see the shadow. So this collection is going to be indirect only. We cannot turn it off completely because we lose the shadow. There's no object casting any shadow. So we need to turn it on and just leave it on indirect. That's for the background. Then change the active layer to foreground. And now we want the exact opposite. We just want to see the models, but not the shadow. So same thing, we're gonna click on indirect only on this collection. So now we have the foreground with our models and the background only with the shadow. We go back to compositing, Shift A, render layers, change this to background. And of course the shadow has to be below the models. So we're gonna cut this, place this image here, then select this and this, Control-Alt-0 on the numbers pad, move this here. Now we're nesting these two alpha overs. We don't see anything because we need to render it again. So let's go ahead and do that. You'll notice that it takes longer because it's now pretty much doing twice as much work. It's rendering the shadow, and then separately, it's rendering the foreground. And then it's compositing everything together. So it will take a little bit longer. Okay, this is what we have now. Let me move this away. And now here we have the background, that's the image, the shadow, and the models. So the column and the sphere. Everything is very neatly organized. The shadow, we can just make it darker. So let's add an RGB curves. Place it here. And there's a couple of ways to do this. We can just move this point to the right. Okay, you'll see that it's modifying the whole image, except the models because these are placed on front of the image. So to fix that, we can just connect the alpha to the factor. That's way too much, so we can go back a little bit. Okay, maybe something like that. Okay, I think that's decent. It's too dark, but we can still see the camera shadow here. So I think this is the best we can do. Now, the final thing we want to do, and this is very fine tuning. This is kind of psycho territory, but it makes your renders that much better. We're going to add a little bit of noise to the render and blur it ever so slightly so that it more closely matches the quality of the image that's behind it. And that way it's going to be almost impossible to perceive that this is a render. We don't need to do anything with the shadow, so we're just going to do that to the actual models. The way we do that is we're going to add here a texture. Let's add a new one. I'm going to make this bigger and rename it to grain. Now here in textures, with the grain texture selected, we're going to change this from image to movie to distorted noise. Now, if I connect this directly to the viewer, you'll see that it's stretched on the x-axis. So we need to change this scale. And the exact number that we use is we go here to output, and it's this ratio. So 38040 divided by 2160. So we just go ahead and type that, 3840 divided by 2160. Let's go back here. Noise bases, I think they're all good. I just use improved Perlin because...
So before I scale it down, take your noise basis and change it to anything, just a more interesting pattern. I'm going to use improved Perlin.
Let's change the size to something like 0.001. And now Shift Control, right click and drag between these two to create a mix node that we're going to set to overlay. Now we're going to connect this here. We zoom in, and what we want to do is to match the pattern as best as we can. It doesn't need to be exact, it's very forgiving, but we need to match the size of our noise to the size of the noise that's in the image that we took. I mean, to me, this actually looks pretty good. Maybe a little bigger. Actually, I'm going to go to 0.002. So I think in this case, 0.003 looks good. And then we want to change the factor to a very low number, something like let's say 0.1 first. Yeah, it's too strong. Let's do 0.05. And finally, we're just gonna ever so slightly blur so that it's not so sharp. If you see anything else in the picture, it's not as sharp as this, obviously, because these are real things and this is a render. So let's blur it before we add the noise. Shift A, blur, place it there. I'm gonna zoom in so that you can see what's happening. And this has to be a really low number. If we do something like 5, it's too much. It already looks out of focus. It doesn't look bad, but it looks out of focus. So this has to be between 2 or 3. So that's 2. That's 3. I'm going to set it back to 0 so that you can see the difference. So that's 0. That's 2. It's ever so slightly blurrier, but these details really help to sell the image. And the last thing that I want to do is, if you look at the ground here in the reflection, this looks more red than the ground in the actual photograph. So we're going to try to match a little bit. Again, it's very forgiving. We don't need to be 100% precise, but we do want to match the saturation of the colors here to these ones. So we can do that by going back to shading. Here, let's go to rendered. Let's select the foreground layer because we want to see the model. And here we can add an HSL, hue saturation value node, place it there. And I think if we reduce the saturation a little bit, that's going to be enough. So saturation 0.9. What about that? Let's say 0.8 maybe? Or is that too much? I think that's actually pretty good. So let's render it again. And this is our final image that 90 or 95% of people will not be able to tell that there's a render on top. That's it for today's video. I'm Dude Blender. Happy blending.